Grüezi YouTubers, here is the guy with the Swiss accent again. During the last 2 weeks I had to work for money. I was on a project in a foreign country and brought a souvenir with me. Looking at the nice Airbus A380-800 airplane, you can guess that the project was in Dubai. If you want to see how it looks inside this plane and also see my favorite actor, click on the link in the comments. Unfortunately, I did not meet her. For an engineer like me, Dubai is mind-boggling with what humans can do if they want. And, of course, have some spare money left. This is why you did not get a video last week. Back home, I wanted to start with a new video. The reason for that video will be disclosed in one of the next episodes. Unfortunately, a problem with my new 100-watt LED lights reappeared. I had the same problem a few weeks ago on the left LED lamp in my lab and asked the supplier for remedy. He sent me a new 100-watt LED, but before the new chip arrived, the problem was gone without doing anything. So I have a spare LED chip and a problem. In this video I try to solve it. But first, what is the problem? If I connect the LED lamp to 220 volt, it flickers heavily. You might have noticed the effect already in one of my former videos. The flicker is not 100%, but clearly disturbing. To start the repair, I have to open the case of the lamp, which consists of 2 different compartments. LED lights with smaller power usually consist only of 1 compartment, but obviously here the space was too small. The structure is simple and also more or less waterproof, because it was built for outdoor usage. At the end of the disassembly, we see that there are 2 50-watt systems running in parallel. 2 constant current driver modules drive 1 LED chip, but it seems that the chip itself also consists of 2 different 50-watt sections, with no connection in between. The LED chip is mounted directly to the aluminium casted case with a big amount of thermally conductive paste in between. If I connect the lamp to 220 volt, it immediately starts to flicker. Because the light is so intense, the camera chip is completely saturated. But if we look close, we see that there is probably a difference between the behavior of the left and the right part of the LED. And after I disconnect it, we see a huge difference between the 2 parts. But this is only because we look through the camera and in slow motion. With bare eyes I do not see it because a 100-watt LED is really bright and I have no really dark glasses on hand. Now here comes the part how engineers try to solve problems. First, they try to split systems in its parts and try to isolate the problem. In this case, this is quite simple. I disconnect 1 positive wire to switch off 1 LED. And the effect is now very clear. The right part flashes with 100% intensity. Now I change the wires to power only the left part. This part seems to be okay. Now we know that the right part of the LED shows the problematic behavior. But we still do not know if the LED or the constant current module creates the problem. Because the right part of the LED is driven by a different power supply, this could well be. So engineer's rule number 2 is applied. Replace the component in question with another one you are pretty sure it's okay. In our case, also this is easy. I just connect the second power supply module, which behaved okay with the left part of the LED, to the right LED. It would not be necessary to connect both power supplies for this test. The same behavior of the right part of the LED. This shows that the probability of a defective LED is now very high. So I remove the LED module and replace it with the new one from the supplier. But of course I have to apply engineer's rule number 3 now. Do not assume or trust. Better check yourself to be sure. And this is exactly what I do now using my bench power supply. The new LED clearly shows a normal behavior and seems to be okay. So I can put the new LED at its place and check if the heat transfer from the LED to the lamp case works okay by checking the temperature of the heatsink after a few minutes of operation. Also okay. Otherwise I would get a heat problem a few hours later. Because after assembly the wires will be quite close to the aluminium reflector, I put some Kapton tape as isolation on the contacts. Kapton is quite heat resistive. Now I can reassemble the whole lamp. Problem solved. The lamp is now mounted at its place and will help me in the future to do my videos. And of course also the one which has to do with my return from Dubai. But I still wonder what happened with the LED. So I connect it to my bench power supply and supply it with 25 volts. With this voltage the LED barely works and I'm able to see what happens. Now it is also for the normal eye clear that on the right part of the LED only one row is active. This LED is ripe for recycling. Thank you for watching. I hope this video was useful or at least interesting for you. Bye.